Okay. Let's do it. Yes, okay. Alright, we are starting with Chapter 9, Trigonometric Ratios. In triangle ABC, AB is 5, and AC is 3, and angle A is 120 degrees. Find BC. Yeah, okay. Right, just making sure my brain is woken up. In triangle ABC, AB is 5, in triangle ABC, AB is 5, AC is 3, angle A is 120 degrees, find BC. Alright, then what we do is we use the cosine rule, which says a squared equals b squared plus c squared minus 2bc cosine of a. Alright, so we let A be the line segment BC, and then we'll have B be AB, and we'll have C be BC, and thus 5 squared at 3 squared minus 2 times 3 times 5 times the cosine of 120 degrees. 5 squared at 3 squared is 34. So 34 minus 30 times the cosine of 120. What is the cosine of 120? It should be a negative a half. And thus 34 plus 15, 49, and thus square root. So 7 degrees, 7, rather the length is 7. So 7 is the length of BC in the triangle ABC, where AB is 5 and AC is 3 and angle A is 120 degrees. Okay, a triangle has sides 7, 8 and 13. Find its largest angle. Alright, so first just make sure that it's not a Pythagorean triangle. So 7 squared add 8 squared, 49 add 64, that's 113, not 13 squared, which is 169. So 7, 8 and 13 are the sides of the triangle, so you've got to find the largest angle. Visualize. Okay, it would be the angle between the sides 7 and 8. Okay. Do the cosine rule. So 13 squared equals 7 squared add 8 squared minus 2 times 7 times 8 times the cosine of the angle between them. Alright. Okay. So 13 squared, take 7 squared, take 8 squared, what's that? 56. So 56 on the left, minus 2 times 7 times 8, what's that? Minus 112. Divided by minus 112, what's that? Negative a half. Arc cosine, negative a half, what's that? Oh, 120 degrees. Okay. So 120 degrees is the largest angle in the triangle with sides 7, 8, and 13. In triangle ABC, angle A is 30 degrees. BC is 4. AC is 4 root 3. Angle B is obtuse. Find angle C. Okay. Okay, so we just need angle B. Do you see it? Yes, I see it. All right, so sine rule. Yes? Okay. Sine of 30 over 4 equals sine of C over 4 root 3. Sine of 30 over 4 is 1/8. Times 4 root 3 is what? Root 3 over 2. So you say 60, right? For angle C. Mm-hmm. Why is it not 60? It is 60. Then that means the other angle is 90. Is it 90? Right, so I think it's 90, but we have to try again, because in triangle ABC, angle A is 30 degrees. BC is 4. AC is 4 root 3. Angle B is obtuse. Find angle C. Sine of 30 over 4 that's equal to angle B over 4 root 3, isn't it? Sine, no, that's equal to sine of angle B over 4 root 3. You get it? Okay, so on the left we have a half over 4, which is 1/8, times that by 4 root 3. We have root 3 over 2. So root 3 over 2 is sine of angle B. But B is obtuse, you already know that. Alright, so B is 120. Okay, so if angle A is 30, angle B is 120, then angle C must be 30. No, that's wrong. No, that's right. It's 30. Okay, that's been corrected now. So 30 degrees is the size of angle 30 degrees is the size of angle C in the triangle ABC, where angle A is 30 degrees. BC is 4. AC is 4 root 3, and angle B is obtuse. Okay, next. Sides of length 6 and 10 enclose an obtuse angle. And the area of the triangle is 15. Find that angle. Is that right? Yeah, that's right. Okay, so use the area rule. 15 is equal to half times 6 times 10 times the sine of the angle between them. So 15 equals 30 times the sine of the angle. So the sine of the angle is a half. So it must be 150 degrees. So 150 degrees is the size of the obtuse angle between the sides of length 6 and 10 in the triangle, which has an area of 15. Okay, that's Oh, you're reading it. Not correct. In triangle ABC, angle A is 30 degrees, which is equal to angle B, and AB is of length 6. Find the exact area. Okay, so you need the height of the triangle. Okay, so it's an isosceles, and so we split it down the middle. Three is the adjacent. The opposite is the height, and 30 degrees is the angle. So tan of 30 degrees equals the opposite over 3. Tan of 30 degrees is 1 over root 3. Okay, so the opposite is 3 over root 3. Which is root 3. Right, okay, so 1.5 times root 3, and then divide that by 2, but then times it by 2 again. So 3 root 3 over 2. So it seems like no, that can't be right. That cannot be right. Okay, so I'm thinking that in triangle ABC, angle A is equal to angle B, which is equal to 30 degrees, and the length between them, AB, is 6. We need to find the exact area. Is that right? Yeah, that's right. Okay, do it again. Split it into 2. So 3 on the base, but we don't know the opposite side. So we've got 30 there, 3 there. We don't know what the side is. So just do tan of 30 is the opposite over 3. What's tan of 30? Oh, 1 over root 3. Okay, so 1 over root 3 is the opposite over 3. So the opposite is 3 over root 3, which is root 3. So root 3 times 3 then divided by 2 and times by 2. So 3 root 3. 3 root 3 is the area. So 3 root 3 is the area of the triangle ABC, where angle A is equal to angle B, which is equal to 30 degrees, and AB is 6. Okay. How many solutions does sine of 3x equals a half have for x between 0 and 360 degrees inclusive? Okay, so tripling the argument causes it to be horizontally compressed. As in, there'll be around 3 times as many solutions, but we need to find the exact answer. So ordinarily that would be just 2. It should be 6. The answer should be 6. And what are those? $10 and $50. $130, $170. $250, $290. It should be 6. So 6 should be the number of solutions of sine of 3x equals a half for x between 0 and 360 degrees inclusive. Give the coordinates of the maximum of the function y equals 2 plus sine of x at 60 for x between 0 and 360 degrees inclusive. It should simply be 3, but they're asking for coordinates. And so there are multiple. Well, okay, so there are multiple possible answers. So, no, there's not. That's wrong. Alright, so we already know that the y coordinate is going to be 3. So now find the x coordinate. Adding 60 to the argument translates the whole function 60 degrees to the left. And therefore it should be that's right, isn't it? Yeah, that's right. So it would be 30 degrees, 3. So 30 degrees, 3 should be the coordinates of the maximum turning point of the function y equals 2 plus sine of x at 60 degrees for x between 0 and 360 degrees inclusive. Give the smallest possible value of x for which tan of 2x is undefined. The smallest possible positive value of x for which tan of 2x is undefined. Okay, multiplying the argument by 2 has the effect of horizontally compressing it, and so the asymptotes move twice as close. So the answer is 45 degrees, right? So 45 degrees should be the smallest possible positive value of x for which y equals tan of 2x is undefined. Okay, chapter 10. Chapter 10. Cosine of x is equal to negative root 3 over 2. For x between 180 and 360, excluding the ends, find x. It's 210. 210 degrees is the value of x when cosine of x is negative root 3 over 2 and x is trapped between 180 and 360. Evaluate tan of 240, take sine of 210, and write your answer in the form a plus b root 3. Tan of 240 is root 3 over 3. No, wrong. Tan of 240 is root 3. Sine of 210. Minus a half. So subtract it. Alright, positive a half. So a half plus root 3. So 1/2 plus root 3 should be tan of 240 minus sine of 210. Sine of theta equals 3/5, and theta is obtuse. Find tan of theta. Right, so obviously it's the 3, 4, 5 triangle that we're looking at here. If sine of theta is 3/5, then yeah, because I'm tempted to say it's 3/4, but I know that that's not right. Well, I'm not sure how to do it then. Alright, so I need to remind myself how that works. Right, 1 minus cos square. Right, 1 minus cos squared theta over sine theta cos theta as a single trigonometric ratio. Okay, so the numerator is a Pythagorean identity. So that'd be sine squared theta. Cross off sine theta on the top and bottom. So you get sine theta over cos theta, which is tan theta. So tan of theta is 1 minus cos squared theta over sine theta cos theta as a single trigonometric ratio. Solve tan of 3x equals 1 for x between 0 and 180 degrees inclusive. Alright, multiplying the argument by 3 has the effect of the period shrinking down by 3. Okay, so anyway, tan of 3x is equal to 1, so the answer was 45 degrees in the ordinary sense, but now it's going to be 15 degrees. Alright, so 15 degrees, 75 degrees, and 135 degrees. Okay, so that's wrong. Tan of 3x is equal to 1, right? Right. Now, usually it's 45 225 and 405. But those must be halved. No, 1/3. So 15, 75, and 135. And that's right. Okay? Right, so tan of 3x is equal to 1, and x is between 0 and 180 degrees, and the solutions are 15, 75, and 135. Okay. Solve 2 sine squared x plus sine x. Take 1 equals 0 for x between 0 and 360 degrees. Alright, let y equals sine of x, then 2y squared plus y, take 1 equals 0. And then solve by factoring. So 2y take 1 times y plus 1. So a half and negative 1. So we have to solve sine of x equals a half and sine of x equals negative 1. And the answer is 30 and 150, and then 270. So for 2 sine squared x plus sine x, take 1 equals 0. For x between 0 and 360 degrees inclusive, the solutions are 30, 150, and 270 degrees. Solve 2. No, misremembered. Solve 2 tan x sin x equals 3 for x between 0 and 180 inclusive. Two tan x sin x equals 3. So tan x sin x equals 3 over 2. tan x, sin x. Tan x is sin x over cos x. So it becomes sine squared x over cos x, which is 1 minus cos squared x over cos x. We have 3 cos x on the right, and 2 times all of 1 minus cos squared x on the left. So 2 minus 2 cos squared x. Put it on the right. 2 cos squared x plus 3 cos x. Take 2. 2 cos squared x plus 3 cos x. Take 2 equals 0. Let y equal cos x. Then it becomes 2y squared plus 3y. Take 2 equals 2y take 1 times y plus 2. Y plus 2. Abandon solutions for that. 2y take 1. Y equals a half. Cos x equals a half. Answer. 60 and 300. So 60 and 300 appear to be the solutions for 2 tan x sin x equals 3 for x between 0 and 360 degrees inclusive. Oh no, wait, you have to abandon one of those because it's between 0 and 180. 0 and 180. Okay? Okay, next. Solve cosine of x take 30 equals 0 for x between 0 and 360 degrees inclusive. Subtracting 30 from the argument shifts everything to the right by 30. And therefore the ordinary solutions of 90 and 270 become 120 and 300. Given vector A equals 3i, take 4j, find the magnitude of vector negative 2a. Okay, so the magnitude of that will just be twice the magnitude of A, which is obviously 5, and therefore the answer is 10. So 10 is the magnitude of vector negative 2A when vector A is 3i take 4j. Find the angle between negative I plus root 3j and the positive x-axis. So we see that tan of theta is equal to root 3 over 1, so that would be 60. So we take 60 from 180, so 120 degrees. So 120 degrees is the angle that negative I plus root 3j makes with the positive x-axis. Point A is 1, 5. Point B is 7, negative 3. Find the position vector of the midpoints of AB. So we have 1, 5 and 7, negative 3. Their midpoint is 4, 1. And the position vector is 4i plus j. 4i plus j is a position vector of the midpoint of AB when A is 1, 5 and B is 3, negative 7. And B is 7, negative 3. Point P has position vector 4i take j. Point Q has position vector I plus 3j. Find the direction vector P to Q. As in, how do you get from point P to point Q? That's really what it's asking. Minus 3i plus 4j minus 3i plus 4j should be the position vector p. No, minus 3i plus 4j should be the direction vector p to q if point P has the position vector 4i minus j, and point Q has the position vector I plus 3j. All right. Pause there.